Hey guys, what is up? Welcome to another Leetcode problem. Today we're doing problem 1625 lexicographically sum a small string after applying operations. You're given a string S of even length consisting of digits from 0 to 9 in two integers A and B. You're going to apply either of the following two operations any number of times in any order on S. Add 8 to all odd indices of S. Digits post 9 and cycle back to 0. For example, S equals 3, 4, 5, 6. Take the odd integers, add 5 to it. Add A, which is, what is it? 5. Oh yeah, A equals 5. S becomes 3, 9, 5, 1 because 4 plus 5 is 9. And 6 plus 5 is 11, but you're going to cycle back to 0, so it becomes a 0, then 1. Just take the second digit in the number, which is 1. 5 plus 6, 1. 11 second digit is 1, so just put 1. 3, 9, 5, 1. That's that. Or we have another operation we can do, which will rotate S to the right by B positions. For example, S is 3, 4, 5, 6, and B equals 1. You just rotate it to the right, and that 6 comes over back to the beginning. We're going to return the lexicographically small string you're going to obtain by applying the above operation any number of times on S. If you're doing these problems enough, you know what lexicographically means already. But yeah, this is that. In this case, it's just a smaller number. The smallest number is the lexicographically small string. The way we're going to approach this problem is very simple. We have two operations. We can either rotate or we can add. We can either rotate by B indices or add every odd digit answer by A indices. Okay. So what we're going to do now is we're going to grab all these possible sets or variations that we can from this, okay? So for example, what I mean by that is we're going to just try all the possible combinations. But not really all the possible, we're not really generating subsets. So for example, we have 5, 5, 2, 5. Now from there, we can either do what? We can either rotate or add. We can either rotate or add, right? Let's do it like this, rotate or add. And after we rotate from there, we can either rotate or add, right? And then from this one, we can either rotate or add. So at every step, we can either take two operations. We can either rotate it or we can add. We can either rotate or we can add. We can either rotate or we can add. That's all it is. It's a simple DFS. At the end, at each rotate at the end of each, at the beginning of each DFS call, meaning every time we go into the rotate or the add, right? We're going to compare if that current string is less than or lexicographically less than our previous minimum, then we're going to set that as the minimum. Okay, so really simple. Let's just go through it really quickly. This is the problem. Find lex smallest string S int A, B. Also, the answer came from the same guy for all three Leetcode problems. Well, he's on the roll today. He's number 1 in oldie solutions. Right over here, really good answer. Check out his website. Check out his YouTube channel. I think he has a YouTube channel. I haven't found it yet, but he mentioned he does in one of his posts. But yeah, so we have answer is equal to S so far. That's our current minimum so far. And then we're going to set A and we're going to set B because we don't want to keep passing it around. Then we're going to call the DFS, and then at the end of it, we're going to return the answer. And the DFS is going to set our answer. What is DFS going to do? It's a depth first search. Remember, we're either going rotating or adding, rotating or adding. I'm going to keep going. So if we already visited the string before, we're going to just return. And this is basically our base case. Eventually, we're going to have visited all the strings and we're just going to keep returning. Next, we're going to check if this string is lexicographically smaller than the current string lexicographically than our current minimum. Answer is basically like the minimum smallest lexicographically string. So if answer compared to string is greater than 0, and that means if answer is greater than string, it will return a positive number, which is 0. That means string is less than answer. So we set answer to string because it's minimum. It's less than that. Then all we gotta do is we add this string to our set because we visited already. Then we just, once again, we call DFS of add and DFS of rotate. We add and we rotate. This answer is really intuitive. It's really just, I like this answer a lot. We have add and we have rotate. For rotate is very simple. We're going to get the substring of n minus b to n because we basically, depending on what b is, we're going to cut off that much b from the beginning, and we're going to pull it and we're going to put it to the back. That's all it's doing. So you're cutting off the back part of b of size b, right, to the end, and then you're basically putting that in the back. That's why you're plussing it first, and you're adding it to whatever was in the beginning section. And for add, also very simple. We're going through all the strings. This problem is mainly just understanding this part, that's a DFS approach, and writing a solution really cleanly. We have a string builder. We're going through the string. And if it's an odd index, right over here, we'll append this character to the string over there. Right, as that append string car at I. We'll append the Oh, sorry. If it's an even character, we just append it in, right? Because we're not adding the even characters. But if it's an odd character, then what we do is we what is this doing? Oh, s dot car at I minus over here will give you the number, right? It'll give you the number of the string, right? Because, for example, if our current character was 5, and then we're subtracting it by 0, right? These are 5 units apart. So when you subtract these two characters by one another, you'll get 5. Okay? That's how the characters are made in Java. And most any programming language. So you're gonna subtract these, or anything that uses ASCII or Unicode, I think. But yeah, so you're gonna subtract these, then you're gonna add a to it. So now this is the number. The digit is basically the character is converted to a number. And you just add a to it, and then you modulate by 10, and you get the remainder. And the remainder is basically the right digit, right? That's basically what does the cycling. As we mentioned, we do 5 plus 6 is 11, and then you have to modulate by 10. 11 modulo 10 will give you 1, because 11 divided by 10 is a remainder 1, and that will give you 1. And so you just append 1 to it, and that's that. Then you take the string builder that we're adding the new string into, and we just return that. So that's how we add, that's how we rotate. Once again, it's the DFS. You either add or you can rotate. Thank you guys for watching. Please subscribe if you haven't already. Please leave a like if this helped, and I'll see you guys next time.